Happy Friday the 13th, everyone. Please make sure that you have the notes for today and you can take out your blue packet right now. I want to make sure that we fill in some of the questions. Our test is going to be Thursday of next week. So if you need to pause this while you take out your blue packet, please do so. Okay, so on Monday and Tuesday of this week, we looked at how can we compute the least squares regression line by hand. This is question 6 in your blue packet. If you remember the steps, we are given the formulas for the slope and the y-intercept on the AP formula booklet. You have to first, and most importantly, identify your x and y. Remember, your y is what you are going to predict. You're going to use x to explain y. Remember, x is our explanatory, y is our response. Identify the mean, the standard deviation, so x bar, standard deviation of x, y bar, standard deviation of y, and the correlation coefficient, which is r. Then use the formulas. Slope comes first. Remember, slope is change in y over change in x. That's where this slope formula comes from. It's the correlation times the change in y over change in x. Your correlation, if it's positive, will have a positive slope. If it's negative, will give a negative slope. Once you do that, you can find the y-intercept and then write the line identifying x and y in context. So this is where you need to say things like number of aircraft and years. The other question I want to answer is question 10. That's about what you looked at yesterday in a residual plot. So a residual plot is a graph that shows the x values, most often it's the x values, against the residuals. Residuals are the errors between the actual points and what the LSRL predicts. So it is that difference between the physical point and the line. So to calculate a residual, it's actual minus predicted. What we want to see is no pattern or noise. And that tells us that the original data is linear because the points will fall above and below the line nicely. If we do see a pattern, that tells us our original scatter plot is not linear. And these are some notes that you took down yesterday, so you might want to have those out as you go through today's packet. So those are the two questions from the blue packet I wanted to answer. So now you can put your blue packet aside. I'm actually going to do one question with you today. So in your notes packet for today, we're going to look at a residual plot. So, in the study of application of a certain type of weed killer, 14 fields containing large number of weeds were treated. So you can read through this, you can pause this. We have the different strengths of weed killer, okay, in terms of number of teaspoons against the percent of weeds that it actually killed. So we're thinking about spraying on the lawn. We have the computer output below, things that we want to know. The dependent variables are y variables, so our y variables percent. We have r squared here, which is the coefficient of determination, and then we use this portion of the table to get our line. The question here is, what is the equation of the least squares regression line? Define any variables used. So I know my x variable is number of teaspoons, so my slope is 24.3929. So my line is going to be percent killed, so remember that's our dependent variable, equals our slope times our x, and then our constant or our y-intercept minus the 20.5893. Okay, looking at part B. Again, same question. Now it says, is a linear model appropriate? Explain how you came to your conclusion. So the only way you can tell if a line, that's what they mean by linear model, is if a linear pattern is appropriate, is if when you look at a scatter plot, you see a linear pattern, or a residual plot, you see noise. This is a graph of a residual plot, and I can see that because residuals is what's labeled here, and it says a plot of residuals is provided. From this, we usually have a line at 0 going across our page, but we don't. And even without that, you should be seeing this distinct curved shape. So what that then tells me is that a line is not appropriate because the residual plot shows a curve. That's how we're going to explain how we came to our conclusion. Okay, so the relationship between number of teaspoons and percent of weeds killed is not linear. Okay, part C, I gave the answer away. If someone used this equation to predict the percentage of weeds killed when 2.6 teaspoons of weed killer are used, so this idea of percentage of weeds killed when 2.6 are killed. So I'm going to plug that 2.6 into my line, and that tells me, okay, 42.8% is going to be killed. That's my predicted. Remember, predicted here is on my x-axis, so I'm going to look at where is 42 on this predicted. So I see these 2 points. When I look at the graph above, I see that 42.8 has a negative residual, which tells me then the prediction is going to be too large. When I get a negative residual, that tells me the prediction will be too large. So this was kind of a two-step question. I needed to figure out, sorry about that, I need to figure out the percent of weeds killed when 2.6 teaspoons were used, so we're using our line. We're using that prediction to read the graph to figure out will the prediction be too large or too small. So at this point, what I'd like you to do is you can pause, you can go back earlier in this video if it will help you. I want you to take out your blue packet. You are going to need that. This next question, that's my hint to you. Use your blue packet to help you with those sentences. Okay, so you are going to finish this packet. Whatever you don't finish in class is homework. You should right now have about 35 minutes to work on it. Good luck and have a nice weekend.